Okay, I'm on page 10 of our packet, and we're going to be going over how to condense a logarithm. So on Friday's class, we learned how to expand a logarithm, and now we're condensing it back up. So we're going to use the same properties that we went over. So we went over the quotient property, we went over the product property, and we went over the power property. Now on page 10, I took these notes for you, so you don't have to write anything down just yet. On the next page, we're going to be writing down another example. So I want us to look at this example first. So here we have log of base a x plus log of base a 9. That's the first part of our problem. Since the expanded form, I'm adding the two different logs. If I'm putting it together, that means that if I'm scrunching it together, it's going to be log of base a 9 times x. So now we're working backwards. Whenever we have added logs, if we're putting them together, we multiply. Now, here I have log 9x plus log x squared plus 1. Since I'm adding these logs together, if I combine it to one log, I'm going to multiply 9x times x squared plus 1. So here's that multiplication there. So now I took care of that part. My last part, I have this log minus 2 log of base a 5. Since I am subtracting the logs here now, that means I'm going to divide. So I'm going to divide the 9x times the quantity x squared plus 1 by the log of base a 5 squared. So in this step, I actually brought that 2 up as an exponent. We're working backwards now to scrunch it up as much as possible. So 5 squared I know is 25, so I put that as my denominator because I was subtracting, so I want to divide by 25. You should always just have one log in your answer. If we're condensing, that means you should only have one log. I should never see more than one log in your answer if I'm condensing to one. Alright, in this right-hand column, this justification, I justified all of my answers with the three properties that we went over. The product property, the power property, and the quotient property. On Illuminate, a lot of questions require you to justify your answer, so you're going to have to use those three properties to prove how you condensed or how you expanded the logarithm. Let's turn the page over to page 12. So I'm on page 12, and I'm in the middle of the page. I'm going to go over these 4 examples on how to condense logarithms. So going over the first example here, let me zoom in so you can see it a little bit better. The first thing that I like to do is any numbers that are in front of the log, I bring back up as an exponent. Usually we've been in the habit of bringing them down, but now that I'm working backwards and I'm condensing, I'm going to bring all those numbers back up. And I don't have any other numbers in front of the log. So this is going to be log 6 plus log 2 squared minus log 3. Now these two logs I'm adding, so if I want to put this in one log, that means I'm going to have 6 times 2 squared. And then I'm subtracting this log, so that means I divide. So on the bottom, I'm just going to have the number 3. And I can reduce this if I want. This would be log 2 squared is 4. 4 times 6 is 24. And then 24 divided by 3 is 8. Alright, let's look at the second example. I have a 1/2 in front, so I'm going to put that as an exponent. I have no number there, so that's log of base b 20 to the 1/2 power minus log of base b to the 4. So because I'm subtracting the two logs, if I'm putting it into one log, I'm going to divide the two. So 20 to the 1/2 divided by 4. If I want, I can try and reduce this radical. I'm going to change this into a radical form. So log, my 2 is in my denominator, so that means that's going to be my root. And then inside I just have 20 to the first power over 4. And I can simplify the square root of 20. So I'm going to do this little note up here. The square root of 20, any two factors, I'm going to say 5 and 4, and then 4 becomes 2 and 2. So because I'm talking about a square root, I have one pair of 2's. So the one pair of 2's can come out. So this would be, excuse me, 2 square root of 5. So the reason why I simplified to this is 2 square root of 5 over 4. Now I can reduce this. 2 over 4 is the same thing as 1/2. So my most simplified answer here is log square root of 5 over 2. Alright, let's go to the next example. Natural logs are the same steps as logs. So any number in front goes to an exponent. Oops, that should have been to the x there, my bad. This -2 goes to the y, the 4 goes to the z. So this is saying the natural log of x to the third minus the natural log of y squared minus the natural log of z to the fourth. So if I'm writing this all in one natural log, this x to the third is a positive natural log, so that's going to be on the top. And minusing the y squared, so that goes on the bottom. Minusing the z to the fourth, so that goes on the bottom. And I can't simplify that anymore because they're all different variables. Alright, last one. Notice that my 1/2 is outside of parentheses in this example. So the first thing that I want to do is I actually want to distribute this 1/2 to both of these logs. So this is going to turn into 1/2 log 16 minus, okay, so this 2 times the 1/2, I'm going to do this on the side. 2 over 1 times 1/2, that's 2 over 2, which reduces to 1. So this is actually minus 1 log x. And then the plus log y, I didn't have to distribute anything because this was alone. It was outside the parentheses, so I just leave it on the outside. So I don't really need this minus 1 here. This 1 is invisible, so it's like you can kind of ignore it. But this 1/2 needs to go up as an exponent. Again, you could bring this 1 as an exponent, but x to the first power is just x. So this gives me, log of 16 to the 1/2 minus log of x plus log y. So whenever I see addition, that means it's going to be in the numerator. When I see subtraction, it's going to be flipped to the bottom, to the denominator, because it's dividing. So writing this in one log. First of all, 16 to the 1/2. This is the same thing as saying the square root of 16. So let me write this here. 16 to the 1/2 is the same thing as if I were to write this in a root. The 2 goes here and 16 is here. We know the square root of 16 is 4. You guys should get that down. 1/2 to the 1/2 power is always square root. So I'm going to change this. Instead of log to the 16 to the 1/2, I'm going to say this is actually log 4. So I have 4 here. I'm dividing by x, since that was subtraction, and I'm multiplying by y, since that was addition.